Okay, good afternoon class. You're on to Mamu with Jarvis, and we continue with our mathematics experience, algebra, looking at the matter of factorization of quadratic expressions. We've done 3 videos. We've tried to look at more or less the introduction into quadratic expressions, 1. We've also tried to look at the direct product method. We've looked at a no-show method. We've also tried to look at handling the coefficient of terms, as it were. Today, we are going to the main work, which has to do with factorization of quadratic expressions. Before we go into saying anything, let's take a hypothetical case. Now, we said that a quadratic expression is a trinomial. So let's take a quick summary. We look at a trinomial. We imagine one of it being your quadratic. And the quadratic is gotten by multiplying binomials. So when I multiply 2 binomials, what I will get is a type of trinomial, which I have called the quadratic. So this is what we're looking at. So let's mirror this into the board and see what it will really look like. It will mean that if I have a plus b, a plus 2 rather, into a plus, let's say 1, what I'm going to have will be, I could use my no-show method. So I'll just go ahead and use my no-show method, Starboy Wakanda. Okay, so let's use that first. So by that method, star dot star dot star. I take care of the first times first, a squared, last times last, 2 with a plus, and then crossbow. If you forget your Wakanda, you can remember your crossbow. Crossbow was a very prominent character in them. I think that should be Civil War. I think that should be Civil War. I think Crossbow, one of the most outstanding characters that had to handle, give Captain America a run for his money. Now, we cross it out. Last versus first, that's 2. Remember our rule in here, 2a. Then first against last, and that's a. So that will give me 3a. So I'm going to have plus 3a. And this is my no-show method. But what we are going to do will require us to use the direct product method. So let's go with the direct product method so that you appreciate what we are going to do. If I go my direct product method, I take the contents of this container to multiply this container. And then I take the content, the second content. Remember that the sign is very important to multiply the second container. What I'm going to have will be what? A squared plus what? A, is that not? Plus 2a plus what? 2. Please follow me closely. And what I'm going to have finally will be a squared plus 3a plus 2. Now, what you would observe if you have paid attention to what we are doing is that we obtain these two terms will give me this term. Is that not? So it is safe for me to say that to obtain this term, I simply sum. To get this term here, I simply do what? I sum. Now, another important observation you're going to get now is this. To get this term, I multiplied, is that not? And to get this term, I multiplied. So, when I want to get the factors, which is something we'll be going into, I will now do what? Multiply these two. So, this will be product. So, the first 2 terms, the first and the last terms, we obtain them by multiplying. Look at it, this times this. First to first, last to last. Do you get it? So which means that essentially this position and these positions are product positions. So I look for a way to connect all together, and what I'm going to have will be what? Product. Now, how do I get this one? I got this from my Wakanda crossbow technique. And whatever I get here, I must do what? I must add. So I will treat this as what? Sum. We'll pause here and then we'll continue with a bigger explanation and then come back to explain in details why these concepts are very important. Okay, so we just tried to introduce the concept of factorization of quadratic expressions by trying to connect the binomial to the quadratic. Now, to handle factorization of quadratic expressions, you need certain ideas. Number one, you need to draw from your knowledge of factors. Factors. You were taught factors in your JSS 1 and it was heavy in your JSS 2. That's your grade 8 experience. That's one important concept you must not forget, because the whole idea of factorization means to get out factors. And one of the examples I always use is that to talk about sucking out. For instance, if I have the number 6, I can suck out 1, I can suck out 2, I can suck out 3, and I can suck out 6. So these are factors I can suck out of what? 6. Bear this in mind, every number is a factor of itself. Every number on planet Earth is a factor of itself. So keep that on the one side, but that's not what we're going into essentially. Now, another important thing you must take note of is I talked about the concept of even and odd. Numbers essentially are either even or what? Odd. We said that a number is even if it ends with what? 2, 4, 6, 8, or 0. Whenever a number ends with 2, 4, 6, 8, or 0, we say that that number is what? Even. So when do we say a number is odd? A number is odd essentially if it ends with 1, 3, 5, 7, and 9. Please keep these ideas, because this is the template for how my own model for looking for the factors of the quadratic expression works. It works with your simple understanding of these concepts. Now that's for even and odd. This has to do with the type of numbers now. Now, there is another concept you need to take note of. It has to do with the operation, or let's call it our concept of integers. Integers and operators. And the operators we are considering are plus or minus. We are considering what? Plus or minus. Maybe I should write it this way so that somebody doesn't get confused. So I'll write it plus or minus. Plus or minus. Or I could talk about integers in the manner of whether the number is positive or what? Negative. So these three concepts put together would help us in factorization. Notice I'm taking out time to build the concepts gradually, because we're going to take them one after the other, and then finally we're going to have what is called the end game, where we pull all the characters available to one wall, factorize the quadratic expressions. All right. Okay, so we have the behavior of even and odd numbers. So I've said let E be even and let O be odd numbers respectively. Now essentially when we talk about even and odd, we are picturing a scenario where they are what? Whole numbers. Essentially whole numbers can either be even or odd. Okay, so we're going to subject this to different environments. So the first case, we will subject these numbers to what is called the addition environment. Addition environment. So what happens in the addition environment? I pick an even number, I add it to another even. What do I get? I pick an even number, I add it to an odd number. What do I get? I pick an odd number, I add it to an even number. What do I get? And I pick an odd number and add it to an odd number. What do I get? Now, maybe we should take that a little so that we don't waste so much time. Alright, so I've thought of a better way to handle this so that we wouldn't have to. So when we add even to even, what do we get? We use what I call the example approach. I take an even number 2, I take another even number 2, I 4, and that will give me 6. So if I add two even numbers, I must get what? An even number. Must get an even number. Now let's go to number 2. If I take an even number and I add an odd number, what do I get? I take a case 2 and I take an odd number, let's say 5. And what do I have? 7. And 7 is an odd number. So anytime you add an even number to an odd number, what you get is what? An odd number. We take another case. We take an odd number and add it to an even number. What do you get? So let's take that. So we flip. Okay, let's take another one. 3 plus, let's say 4. What do we have? We're going to have 7. What is 7? 7 is what? Odd. Now we take another one. Let's say we take odd plus odd. What do we get? 3 plus, let's say 5. And that will give us what? 8. So odd plus odd will give you what? Odd. Odd plus odd will give you what? Even. Even. 5 plus 3 will give me 8. So what you discover, a lot of students don't pay attention to these details, but they are very important, because this is what you're going to need when we are dealing with the factors. If I add up two numbers that are even, my answer will be what? Even. If I add up two numbers such that one is odd and the other is even, my answer will be what? Odd. If I add up two odd numbers, my answer will be odd. Even rather. Now, this same scenario is what you have in the subtraction environment, but let's test it out. Now, in the subtraction environment, we have this. Even minus even. What would that give us? We take any case of our choice. We can say 2 minus 4. What we have is a negative 2. 2 itself is what? Even. It's still even. So we take even minus odd. We take any case. Let's say 2 minus 3. We get what? A negative 1. The reason why I'm doing this is because a number even or odd, whether the number is negative or positive, is still, we're not considering the signs, we're considering the nature of the numbers there. So if I subtract an even number, or if I say even minus odd, what I will get will be odd. Now let's take 3. Let's say I take odd minus even. So let's say 5 minus 2. That will be 3. So that means the answer must be what? Odd. Now let's go to number 4. I have what? Odd minus odd. I take 5 minus, let's say 3. 5 minus 3 is what? 2. So the conclusion is that it is what? Even. So from this, we can draw a conclusion. So we can say, irrespective of the case environments of addition or subtraction, irrespective of the case environments of addition or subtraction, comma, we conclude the following. So irrespective of the environment, whether you are carrying out addition or subtraction, we can draw the following conclusion. Alright, so this is our conclusion. 1, that at the negative, or rather even, whether you are adding or you are subtracting, will give you even. Number 2, even plus or minus odd, or odd plus or minus even, we always give you odd. And what's the last important conclusion? That even odd, adding or subtracting another odd must give you even. These are the three basic conclusions we draw from this topic. We must keep this in mind. It's so important. A lot of students learn maths without taking into consideration this aspect. So if I think of two even numbers, whether I'm adding or subtracting, I must get even. If I think of two numbers, if one is odd and the other is even, whether I'm adding or subtracting, I'm going to get odd. If I think of two odd numbers, whether I'm adding or subtracting, I'm going to get what? Even. So you discover that the only time you have odd when you are adding or subtracting a number is when you have one as even and the other as odd. That's the conclusion we want you to see from this topic. Alright, so we're taking a case scenario of addition. We have looked at the subtraction environment. Now let's look at multiplication and division. So let's look at multiplication environments. So how does this work? We pick an even, we multiply by even. What do we get? Look at this. We take a case 2 times 2, and that will give me 4. That's even. We take another, even times odd. That will be like what? 2 times, let's say 3. And what I get is 6. So this must be what? Even. I take another one. Let's say I take even or odd times even. And what I get will be, let's take another 3 times, let's say 4. That will give me 12. So my answer is what? Also even. Let's take a final one. I take odd times odd. What does that give me? And in considering that, I'll take something like, let's say 3 times 1. And that is 3. So the answer is what? Odd. So, what then is the conclusion of this exercise? We are not going to treat case 4. Case 4 may not be necessary for our work. Case 4 talks about what? Division. But we're not going to look at division because it does not impacts very little to the work of quadratic expressions by factorization. So, what can we draw from this? We conclude from our multiplication environment. We conclude from our multiplication environment that what? That what? Even times even is equal to what? Even. That when I'm saying even times odd or odd times even, I get what? Even. And then I have what? Odd times odd being equal to what? Odd. So, what's the conclusion here? The conclusion here is very simple. Anytime I multiply two numbers, as long as I have an even number, the answer must be even. Anytime I multiply two numbers, as long as one is even, the answer must be even. That's what we're seeing here. The only time we have an odd number as the answer is when we have both numbers as what? Odd. This is something you must remember and not forget. So that's the conclusion on this one. So let's note that one down. Okay, we will yet look at another aspect that is so important or crucial to our understanding of factorization. And it has to do with the behavior of integers and the plus minus operators. Now, plus will mean what? Addition, from our knowledge of arithmetic. And minus will mean what? Subtraction. So, in this setup, we're going to be looking at 3 case scenarios again. We're going to look at this in the environment of addition. We're going to look at this in the environment of subtraction. And we're going to look at the integers in the environment of what? Multiplication. So concepts are very, very important. And to tell you the truth, a lot of us teachers, we shy away from it. But more often than not, the struggle students have is in this behavior. So let's take the different case scenario and see how this plays out. So we look at the addition environment. Now, a number is either positive or what? Negative. So we start by looking at if we add up two positive numbers. So I'm going to put brackets here. If we add up two positive numbers, what do we get? We test it. I have what? 2 plus, I'm taking any number now, 2 plus 3. What's the answer? 5. Is it positive or negative? Positive. So it must be positive. When you add up two positive numbers, you must get what? A positive. Now look at number 2. If you have a positive and you add it to a negative, what would the answer be? Now it becomes very tricky. I'm going to give you two scenarios now. You're going to see why it is very tricky to draw conclusions early. Now look at this. If I have 2 plus negative 1, that's one case. And then I will flip these numbers now. I have 1 plus negative 2. The answers cannot be the same. This one means that I have 2 naira. Go remove what? 1 naira. 2 minus 1 is what? 1. Now, look at this one. I have 2 naira and I want you to take out, I have 1 naira and I want you to take out 2 naira. You discover that what will happen is this. You only be able to pay 1 naira and you still be owing what? 1 naira. So this is what? Negative 1. So anytime you add a positive to a negative, the conclusion, we cannot tell what the conclusion will be. That's why we have positive or negative. So the answer is dependent on which one is bigger. If the positive is bigger than the negative, my answer will be positive. But if the negative is bigger than the positive, the answer will be what? Negative. So please take note of this. These are the little things that throw you off in an exam setup. Alright, so that's for case 2. Let's go to case 3. Let's go to number 3. I have a negative being added to a positive. What will my answer look like? So I take another case again. I take a negative 3 and I add it to, let's say, a 2. Because negative is, this is negative. And then I flip them. I take a 2 and then a negative 2 and then I add it to what? A 3. You will discover that this idea is not so different from this idea. When you are adding, the key thing you must take note of here is this, which is bigger. If the positive is bigger, my answer will be positive. You look at this now. The positive here is bigger, so my answer must be positive. So this will be 1. In this case, my answer is, my positive is what? Smaller. So my answer must be what? Negative. So this will be negative. So this will be what? Negative 1. So the conclusion is that I will either have a positive or a negative. It depends on which one is bigger. Is that clear? Beautiful. So number 4. What about if I have a negative being added to a negative? What would the answer be? I take 2 cases. Don't draw the conclusion too fast. That's the mistake you're making. You must logically engage your brain. You can take an example. We call this the example approach. Take an example. Take any 2 numbers. I have 2 naira, negative 2. Or rather, I'm owing 2 naira. And I'm owing another 3 naira. To test this method, I flip it again. Negative 3 added to what? Negative 2. I am owing 2 naira and I'm owing 3 naira. It means I'm owing what? 5 naira. If you are owing a debt and you go to take another debt, the debts will add up and you have increased it. The Yorubas will say, I think Yorubas will say gbese. Your gbese has increased. That's how it works. Now, look at this now. I have negative 3 and I'm adding it to negative 2. What do you get? It will still be negative 5. So the conclusion here is this. That's why I said, if you remember, prior to now when I taught you in grade 8, not to grade 9, I had said that if you are adding when you have the signs are the same. See, when you have positive and positive, and you're adding, it will be what? Positive. Is that not? Now, if you are adding two negatives, your answer must be negative. Here you have more. You are owing, big debt. So this will be what? Negative. So what is the conclusion we can draw from all of this? We can conclude that positive plus positive, maybe I should case it. We generally case it just to tell you that this is an integer, this is an operator. The casing tells you which is an integer and which is an operator. So positive plus positive must give you positive. Positive plus negative is also the same thing as talking about negative plus positive, and the outcome is dependent on which one is bigger. Your answer will either be positive or negative. You can't tell what the answer is by just looking at it. You have to test. And we said here, if the negative is bigger, your answer will be negative. If the positive is bigger, your answer will be positive. So that settles that one. I think then the last one we took was that negative plus negative will give you negative. Anytime you add up two negative numbers, your answer must be negative. Alright, so that concludes this talk. We'll now go into case 2. Alright, so we're going to the subtraction environment as it relates to integers. Now in subtraction environment, we'll take the scenarios one after the other. We have plus, minus, plus. We take any two numbers at all. Any two numbers. We'll take 2 minus 3. And then what you do is you flip it. And then you take 3 minus 2. You discover that in this setup, your answer will be negative. Because your negative is bigger than your positive. I have 2 naira and I need to take out 3 naira from 2 naira. It's not possible. I'm only going to be able to pay 2 naira and I'll still be owing 1 naira. Now, 3 minus 2 means I have 3 naira and I have to pay out 2 naira. So I'm going to have what? 1. So what you discover is that the answer will either be positive or negative. You can't tell by just looking at it. You have to test. Now let's go to number 2. In number 2 you have positive minus negative. Positive minus negative. So how does that work? Let's take 2 minus, let's say, negative 5. What would the answer look like? And then let's take 5, we said we'll flip it, minus negative 2. So what would your answer be? Look at it. This will be the same thing as what? 2 plus 5. Is that not? We are borrowing from what we know. Negative times negative must give you positive. Now, negative and negative here will also give you what? Positive. So that will be what? 5 plus 2. This will be 7 and this will be what? 7 also. So my answer is what? Positive. So if I have something, now let me try to paint what this question is like. I have 5 naira or 2 naira and somebody was owing me 5 naira, paid me back. How much am I having? 7 naira. I have 5 naira and somebody was owing me 2 naira, was willing to pay me back. What would I have? 7. That's the scenario you have here. So this is what happens when you have a positive, a negative being removed from a positive. It is as what? Adding. So the equivalence of this is what? Adding. So this is addition. So let's keep that in mind. Now that's for number 2. Let's go to number 3. In number 3, we have what do we have? Negative minus what? Positive. So as usual, we play with scenarios. We're going to have, let's say, negative 3 minus 4. And here we have negative 4 minus what? 3. What do you see here? I'm owing 3 naira and I went to borrow another 4 naira. It means I'm owing 7 naira. I'm owing 4 naira and I went to borrow another 3 naira. That will be what? 7. Now, I will also do another video where I'm going to use number line to explain this. We can actually use number line to explain this concept. Now, from number line, this means negative 3. Position negative 3. And then move 4 steps. Negative means to your left. So I'll count 1, 2, 3, 4. If this is negative 3, this will be negative 4, negative 5, negative 6, and negative 7. So you discover that the answer is negative 7, which is correct in our deduction. So when you have this setup, it means your answer must be what? Negative. So that's what you're seeing here. Now, number 4. We have when we have negative minus negative. Okay, so we have negative minus negative. So here we can take 2 examples. Let's take negative 1 minus negative 2. And let's flip it now. Negative 2 minus negative 1. So what do you notice? Here you're going to have negative 1 plus 2, because negative times negative will give me what? A positive. And then you have negative 2 plus 1. So this scenario is likened to what we have done under addition. We said under addition, in this setup where you have a negative and a positive, the answer is dependent on which is bigger. Here positive is bigger, so it will be 1. Here negative is bigger, it will be what? Minus 1. Now, what that means is that when I have negative and I remove negative from a negative, my answer is dependent. I can't just look at it and tell what it is. My answer is a function of what I know about the numbers. Hear this and watch. If I say negative 1 minus negative 2, this negative 2, because I'm removing it from this, becomes a very powerful number. That's why if you discover here, it becomes what? Plus 2. So it's like saying 2 minus 1. Here, this negative 2 is more powerful. So it's like saying what? 1 minus 2. I have 1 naira and I'm taking 2 from it. And that will give me what? Negative 1. So that clears that case. So what can we conclude? We can conclude that, what can we conclude? That positive minus positive will give us is indeterminate. We need to know which is bigger. Then when we have positive minus negative, we will always get a positive. And also if we have positive, negative minus a negative, minus a positive, sorry, my answer will be negative. Must always be negative. And we can conclude that when I have a negative and I remove a negative from it, My answer is also what? Indeterminate. So I'm going to have either a positive or a negative. It's important when you get back, you practice this. You practice this very, very well. And as you do so, you discover that your maths begins to improve. Alright, so we come to multiplication environment. Here, if I have a positive and I multiply it by a positive, I must get a positive. It's straightforward. Here, if I have a positive and I multiply it by a negative, it is the same thing as multiplying a positive, a negative by a positive, and that will give me a negative. The truth here is this: negative is so powerful that when it cites positive, it's able to beat it up. Negative is so powerful that when it cites positive, it's able to beat it up mercilessly. So the next one, we have negative multiplied by a negative. Negative multiplied by a negative. Now, anytime you multiply a negative with a negative, your answer must be positive. And this is where I usually wonder how we reconcile this. That they say, when they say two wrongs cannot make a right. It is this part of maths that disproves that when you have two wrongs, you can get a right. You've never seen it that way. When you have two wrongs, it's getting a right. Please don't. This does not apply in the real world, but in the realms of mammon, this is very possible. Okay, we spent close to about 30 minutes there about trying to build up a very important concept. More often than not, students always wonder why I go in this direction. To factorize quadratic expressions, you must have a strong grasp of your factors, your integer relationship to plus or minus operations. You need to have an understanding of how even and odd numbers behave. So with what we've done so far, we can now go in to do the quadratic factorization now. And I'm trusting that as we go into it, we will find learning seamless. Thank you very much for this time. Don't go away because we're going into the part 5 of this video. Thank you very much.